Welcome back to the Circuit Revival, where today we're going to take a look at this Nutribullet Portable blender. So I know that Nutribullet make a mains version of this. I think this is the portable one. You can see it's got a little USB-C port on there. So we'll get this out of the box and take a look. I believe the issue was that it's not charging, which makes me think that the issue is probably going to be just the cells. I know that a lot of batteries have the 1860 battery cells, whichever ones they are, and there's a lot of times where they just sort of fail. If they get too low, they stop working. So we'll get it out and we'll have a look and see if we're right. So this thing looks brand new. Got the manual in the box, and it looks like it's never been used really. So I'm guessing it was probably faulty as soon as it arrived. So it's got a little catch on the top, allows you to open up. So there's a bit of stuff on there that needs a bit of a clean, but beyond that it looks pretty immaculate. So if they're saying it's not charging, does it turn on? So we've got a red blinking light there, which I'm guessing possibly means low charge. So what we'll do is we'll get a battery charger, plug it in and see if it's drawing anything. So I've got here just my digital ammeter and a power bank. So we'll just plug this in and then plug this into the Nutribullet and see if it's drawing anything. Absolutely nothing. So as you can see there, it shows 0, 0, 0. So it's not drawing anything at all. So we'll get this open and see if we can work out why. So there's a couple of rubber feet on the bottom of this. I'm wondering whether there's just any screws hidden underneath those. Yep. So just some hidden screws underneath this. It came out nice and easy, and then just underneath that is just some Phillips screws. So we'll just get the P1, looks like it's probably about the right size. Okay, those three are out. Is this bottom just going to come out? Yep, so the bottom just lifts off there. And we've got the two cells and the board there. So these wires are sort of just tucked out of the way. So we get a bit more on this. I'm just going to undo these screws here. Hopefully it should just give me a bit more on the red wire there because it's just stuck behind. There we go. Put that back in so we don't lose it. On the bus side the screws all look the same, which means that I can't get them mixed up. Okay, so just a cover on the battery here. We'll see if we can get that off. It just holds all the wires in place. We'll just pull that off to the side there. We've got the red and the black there, and then a white one. I'm guessing the white one is possibly a current sense, so they are two 18650s at 2000 milliamps hour at 7.4 volts. And they look like, yeah, in series. The board there. So if we try and take this off here, which looks like just the main power connection to the board, there should be voltage on these pins here. So we'll test those. So I'll get our multimeter in voltage DC and see if there's any voltage in these batteries at all. So if we just go on the two pins in the connector, there and there, 4.8 volts. It's quite low. So what happens if we try charge this without the actual main device attached? See whether maybe the motor or something's putting a fault on it. Nope, nothing. That's at 4.83 volts. So I wonder whether maybe one of the cells has gone down too low past the safe charge value and it's just shut down, because we're getting voltage out of it. So sometimes these things have to see a certain voltage to be happy to charge. As is always the way, please don't copy anything I do. They're probably very wrong and can be dangerous. I'm going to try and see if I can get this board out any easier. There's 2 screws here. We'll try just undo those and see if we can lift the board out, give ourselves a bit more room to work. It looks like it's screwed in place at the bottom there as well, so I think I might struggle to get that out. Because there's 2 screws just in the top here and then a couple of screws in the bottom. You can see just down here there's 2 screws, and I don't think I've got anything that'll be able to get into those. But just have a look at this board and see if there's anything that stands out. The fact there's voltage coming out makes me think that the cells are definitely the issue. I might just peel this back slightly to be able to test the values of the cells themselves. Because I don't want to get it too far out, because these covers are there obviously for protection. So we'll try and get this probe under there, this one under there. And we have 3.69 volts. Let me just zoom out so you can see that. So you should be able to see there, minus 3.69 I think it said. Yeah, it's obviously just minus because my leads are reversed. Well, we'll try the other one, because if they're at full charge they should be about 4.2 I believe, maybe. Yeah, so that's slightly discharged, but I wonder if there's any voltage on this second cell at all. Okay, we'll try this one. This one will probably be the right polarity, because I think I've got these the right way now. 3.68 volts. Interesting. So the cells are both charged. So is it just because they're too low in general the board doesn't want to see them charge? Because we're definitely not getting any draw at all. Could also be that my ammeter here is not actually, doesn't have a great enough resolution to show. That definitely looks like it's not pulling anything. So I think it's possible because it's just dropped a little bit too low, and I think if we bump start it, it probably would start to charge. So I think what we're going to do is try and work out how to get this board out. Because I know that with these cells they want to be charged equally, you don't want them uneven. So it'd be good to try and actually charge them straight from the board rather than try and raise each cell individually, because at the moment they are about even, about there's about what, 0.01 difference between the two. I think that maybe they're just a little bit too low for the battery management system here to tell them to charge. So I think I've got in this kit here, this like bendy flex thing. We'll see whether that will work and whether that will allow me access those ones at the bottom. What I can try is I've got a pair of pliers here, and I'll try and see if I can just twist it out. Finally. It seems like it was just pressure fit in there anyway, so I struggled with those for no reason. So if you're ever doing this, as soon as you get those other ones out, it should just pull forwards, and then you can actually get to these screws here. So it's got battery positive and negative on the board. B plus 2, don't really know what that means. And just the switch there. So we should have the same on B plus and minus as we did coming out of the actual board there. So voltage DC again, and we've got 7.37. Oh. .37. So you saw something slip there, and it did turn on for a second. Okay, so we have a blue light. Should probably read the instructions, see what these things mean. So that's showing 7.2, so this should be fully charged. So is the charger port itself damaged? Because we still have no draw whatsoever. Okay, I think I see it. I think the charger port is loose. So we flip this over and we come in closer. Hopefully that translates over. So the charger port is really loose. I think it's actually sort of lifted the pads up and they're broken, so they're not actually getting to where they need to. What I'll do is I'll move over to the microscope, so I think it should be a bit clearer on that what's happening, because I don't think I've just done that. I think it was like that the whole time, which would make sense why there's no draw, but the batteries are charged. Cool, so here we are underneath the microscope, and here's the charger port here, and as you can see there's a bit of flex and it looks like it's broken just here. So just there, looks like it's broken. So I'm a bit intrigued as to how, and you can see the pads lift up. Oh no, maybe it's the other side where it snapped off, yeah. So hopefully you can see on this side here, it's not attached, but on this side it's just holding on. I don't know how we'd get that to stay a bit tighter. I think the only way maybe is we'll fix this up and then maybe we add a bit of hot glue to it just to hold it in place, maybe on the top here. Fill that side, maybe the other side, so it stops moving. Because I don't see how that's going to hold itself in place otherwise. There is that solder on the back, but I don't really know what it's doing. But if we go to continuity on the multimeter, the mode that beeps, if we go from this point to this point, we should get a beep. We shouldn't get a beep, sorry, because it's not attached, but on this side I think we will. No, maybe it's not attached on either side. Because I don't know what this track at the back is doing. But maybe neither of these sides are joined. I don't know, maybe if that fuse has gone as well. I don't know if that P is supposed to be a 0 ohm resistor working as a fuse, but we don't have anything through that. So maybe... no, we do. It's just one of these ones where it's got like a bit of a protective coating over the top. So with this, I would normally advise removing the battery, which I think I might do by just desoldering one of the sides of the battery here. Just take them out of the circuit. So I'll turn on the soldering iron, and then I think we'll just remove the B+ wire here. It always looks like to be a bit of a weak point, because I know that this rubber seal here is going to hold it in place in the actual unit, but in general that's still going to flex a bit. So we might try and stuff some hot glue underneath it just to stop it from moving around as much. Maybe a bit on the side here and just hold it in place. But it seems a bit like maybe it was likely to fail. B- cable out. They did not want to come off. We might just need to try and work around it. So definitely don't do what I'm doing. Should always remove the battery first. So we'll just try and double check those connections again, because we obviously weren't making a good connection through the coating on the board. So we'll just see which side it actually is. Yeah, so definitely is this side, that's the one that's broken, but we might just add some trace wire to both sides just to support it. Hopefully I'll be able to get the solder to melt here so we can add these wires in. Because it's the main power, I think I'll go for a slightly thicker wire. Normally I'd just use copper enamelled wire, but for these I think maybe the stuff I've got is possibly just a little bit too thin. Okay, that's in. Now I'm going to use a pair of ceramic tweezers for this, just in case I do touch anything. So I'll start by cutting it down slightly. And I'm going to avoid this wire at all costs, just because it is the power. Now there's a chance that's the power this goes to anyway, but I don't want to risk it. Okay, I might just snip a little bit more off the top. Make sure all of those bits don't go near anything. Okay, that's in place. Just get a bit of solder on our iron and hopefully just tap that into place. And there we go. I think that's there. Possibly that coating on it still. So let's just grab our multimeter and just test see whether that's there. So continuity, we'll go from here to here. We're just getting around the other side of that, what I'm guessing is fuse. Cool, that's now getting there. Let's give this a test then. Let's plug the charger in and see whether it works. Okay, everything's still a bit precariously placed, but we'll try and plug this in. Okay, that looks like it's immediately just cut out, which normally indicates there's a short on the board. Oh, okay, we're on, and there we go. 0.28, 0.29, and then hopefully you can see those lights going up. 0.3, so it's starting to take a steady charge there. So we'll get this out. We'll try and get this cable out without damaging what we've just done. And then let's just see how we can protect this all a bit. So I think at first we probably do need to do the same with the other side, just in case it goes again, because given how quickly that first one's gone, I think it's possibly not too long until the other side goes. But then once we've done that, what I think we'll do is we'll get some hot glue and then we'll just fill around the area, because then the IPA will take it out once if we need to get it off again. But then it should at least hold itself and stop it from flexing as it is. So here we can see the other side. You can see the bend and the crease just in the circuit trace there, so it looks like it's going to go soon anyway. So we do exactly the same with this. What I might, no, I think I will do the same and start with the charger port side. But again, I'll just try and bring this around a bit so it's a bit easier. Okay, so I've got my new braid of wire here. We'll just come in. Now I need to really avoid the other side of the board here, because I don't want to short these two ends together. Just going to add a little bit more solder to that, because I'm not fully set on how that's in there. There we go. Trim this down like we did the other side. And then I'll use my tweezers to try and bend this round. Okay, that's about in place. Let's get a bit more solder, try and solder in, and then we'll just try and press it down to the board a bit more. Okay, I don't know if that's attached. It's not pretty if it's attached. Yeah, that's perfect. So then we'll try and get this down to the board. See, that's both reinforced there now. And then what we'll do is we'll use some UV solder mask just to cure that in place so it doesn't move, and should protect it a bit more as well. So we'll just start by getting a little bit of isopropyl alcohol, just clean this area a bit, because the UV mask doesn't stick very well. It's not clean. It's hard to tell whether the board is dirty or not, because we talk about all of that coating. You kind of see it on this diode here. It still looks wet, but that's just that coating. So for this, I'm going to use some of this mechanic UV solder mask. Now what I'm going to do is I'm just going to place it onto just this little sheet here, because it often dries out and then tries to fire out loads, and we don't need a lot. So that's already way more than needed. Put that back away. I just need to get my tweezers. And then I'm just going to use these to take a blob. And I'm just then going to cover this whole area in this. And just, I know I shouldn't be using metal tweezers for this, but I'm just going to be really careful not to touch anything else. And then I just have this UV curing device, just this here, which you can turn on. And I'm just going to hold it over the top of the solder mask, and that should cure it and dry it. Because some of these bits are quite thick, it might take a little bit of time, so we'll fast forward through this. Okay, so that should be all done there. So now what we need to do is just try and focus on getting this USB port to be a bit more secure. To be honest, that already is a touch more secure, but I think we can do a bit more. So what I'm going to do is get some hot glue, and I'm just going to stick it at the back here and then melt it down. And I'm going to try and get a bit underneath as well to hold it in place. But what I might try and do is get the glue to fold around. That might be enough to hold it. So I'm going to use my hot air station for this. Let that dry and see how it goes. As it cools down, that might be enough. We might need to just add a bit more. Yeah, that's much better now. So we just need to then get these wires all packed down underneath this. I can't quite remember how they were, but it looks like it was a bit like that. Because the wires look like they sort of want to get back to how they were. So we'll start with this, which I believe goes this way. Ah, okay, so it's actually got some feet in it to make sure you can't get it wrong, which is good. And then this slides in at the top, and then this slides down over the top of that. Okay, some of that glue is in the way, so I can't quite get this in properly. So I suppose this is supposed to support it itself, but it doesn't quite do it, so I might just need to try and melt and spread that glue out a bit again. Just see how that does. All I've done there is just blow the hot glue a bit further around so it's not in one big lump. So we'll just wait for that to cool down again, and hopefully that should allow me to get this piece back over the top. And then it needs to sit in this way because those posts need to line up. So we'll plug it back into the motor. These wires are out of the way again. So I'll undo this screw once again, just this one here, which will allow me to flex the bottom of that motor bearing housing out of the way. And then I can get that red wire behind there again, make sure nothing fouls against anything. So we've got 3 posts in sort of a triangle shape, and they sit like that. So does that go in there? Don't think anything's caught. I think it's just where some of the wires are slightly twisted differently to how they were originally. There's just a bit of tension there. Okay, we're back together. First things first, does it still turn on? Yeah, so we have a blue light. Don't know what a blue light means. Oh. So it works. And then we turn it off. Still have a blue light. Does it turn itself off? Okay, definitely works. Get our charger. And we'll plug in. Is it working? That's slightly worrying, isn't it? Something's not right there because it shuts the charger down. Okay, we'll try and work out what's causing that then. Okay, so we're back open. I'm just going to try it whilst it's not closed up, just in case it was crushing anything. Yes, it has done the same thing there. So I'll get my multimeter again. I'm just going to go across the positive and negative terminals on that charging board there and just make sure they're not just check that resistor there. Oh, I see, it's come off again. We didn't have a good connection, that's why it stopped. There we go, that's soldered back on. Let's try get this back together again. Okay, we're back together again. Got our charger. Let's see if it works this time. No. That must not have been it then. Okay. I think there might be something wrong with this USB tester, because that's just started charging. Because I've just tried the USB-C tester and that's working absolutely fine. So you can see, hopefully there it's gone down, I think, because it's sort of stopped, but it's settled there at 0.15 amps, but it was bouncing around. Let me try the other one again and see whether maybe it is just faulty. Yeah, it's now doing that even with this not plugged in. Oh, there we go. Yeah, so I think there might be something wrong with the other inside the test there, so we can see that's now charging. So all fixed, amazing. And something new to take a look at is why this ammeter is not working properly. Amazing. We'll see you in the next one. So just a little post update here. So I've plugged the ammeter into an actual kind of plug socket to test it. You can see it's charging and you can see the ammeter. So I think the actual problem was just the Nutribullet was too powerful for the power bank I had. So I put the power bank into protection mode each time it worked. But as you can see, plugged in here, it works absolutely fine.